Am I audible? Uh, Hello? Oh, okay. 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 Thank you for confirming. Uh, and there was an internet issue here, so I was not able to join. And then suddenly mic didn't work. So let me start the class. I think, do I have to wait for some more time or can I start now? Hmm. I think I can start. Okay. So let me share my screen. Okay. Please, someone can let me know if my screen is visible. Okay. So today we will be starting. Okay, is my screen visible? Sorry, I didn't confirm. Okay, it is visible. Okay, ठीक है. So today we will be starting with linear regression. I think the introduction to Python we will do tomorrow when we do tutorial hands-on session. I think that would be more fun way to see Python and how the machine learning Python we use in machine learning now. So today we will just go into the linear regression part, and I plan to keep it slightly light today. And as we progress, we will introduce more math and more dense concepts together. So let's just keep today's lecture slightly simpler. So in machine learning. Okay, let me move my. Okay. So in machine learning, there are three topics that are considered part of that we study in machine learning. One is the unsupervised learning, where you have the data set, but you do not have a corresponding label associated with the data set. So consider for an example that you have a data set of human beings, and in each human being can be of a male or a female. And so this label associated to each person is not available, then you have that form of a data set where the label is not available to you. That becomes an unsupervised learning task, where your goal is to identify a cluster of data points that belongs to the same category. And how do you do this thing is called clustering algorithms are there, where you find some similarities between the data points and you cluster them together. So this is one clustering algorithm. There are unsupervised learning has clustering based algorithm. Another one is a dimensionality reduction. So each data points, in general, when you have these data points may have meaning in real world. But for computers to analyze or process those information, it needs to be converted into some form of vector representation, like long vectors of dimension, say 256, 128, all these vector dimensions that you have to convert these data points into some vector notation. And since these vectors are like some of these vectors can be very large. So if I ask you to create a vector of say one of your favorite textbook, it will be a very large vector represent. It will be a very large vector, right? If you associate each letter to some number, then there will become a very large vector of your book. And if it becomes too large, then you cannot actually do any form of processing. So what we generally try to do is that if the vector size, if the data representation is very large, can we do some form of dimensionality reduction, say, so that it becomes manageable and computationally manageable, and we do not lose important information by reducing the dimension. So unsupervised learning forms that set of category where you actually do clustering, finding the data points which are closer to each other, or a different form, the dimensionality reduction, where you want to compress this data such that you do not lose the important information there. Okay. So this is unsupervised learning. The other form of learning is called supervised learning. Here, it's just opposite of unsupervised learning, not just exactly opposite. It's like here in unsupervised learning, for every data point X, you have a corresponding label Y. So for example, consider the task of image classification. So you have bunch of images, and for each image, you have also a assigned category to it. So if you have an image of a dog, then the image label is a label dog. If you have an image of a cat, then the label corresponding to that image is a cat. So every image has a corresponding label to it. And your goal is to either learn this category, that given this image, what is the category, what is the output, find the classification task, or the task would be a regression task where you actually do not have, say, consider an example of a prediction process, say, for example, forecasting. So given these temperature specification, no, not the temperature specification. So consider that I have given you past yesterday's entire weather data. Can you predict tomorrow's data, tomorrow's weather or a temperature? Now, temperature is a continuous value, right? It can be anything in between. Say, if you are all in Chennai, then it will be anything between some 27 to 33. Any number in between this range. It can be 33.1, it can be 30.1, 30.2, any number. And these are continuous numbers. So you cannot actually do a classification here. You need to predict some continuous value. And to predict such continuous value, we call that form of learning a regression task. So classification and regression are two different kind of a task here. And today our focus would be on supervised learning form. So if this distinction is clear, if someone can if anyone has doubt in the supervised learning part, what is the difference between classification and regression? Let me see the messages. No, sir. Okay, there are you don't have any doubt. Uh, Thank you, Monica. Uh, so I'm assuming everyone is familiar with. Achha, how many of you have some knowledge of machine learning or have done some form of some course in machine learning? If you can just raise your hand, that would also do. Can we raise hand in this? Or you can react. You can react or say raise hand by showing that you know something about machine learning before. Okay, none of you know machine learning before. How many of you are taking any machine learning class for the first time? If someone can raise hand. Those who are taking machine learning for the first time, if they can just raise hand a bit. Currently learning. Achha, can someone say something? Like I feel like since no one is interacting, it feels that I am the only one speaking. Okay, one person is raising hand. Okay, thank you. So only one person is new to machine learning. Everyone else knows machine learning.
Sir, classification is a label based and regression is the continue value to find.
Ha 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 ha. Okay, I don't know who said, but thank you, whoever described it. I'm sorry, I was not able to see who was saying though. Okay, but yeah, one of you have explained it properly. That's exactly what I was trying to say. That classification is where you have to find a label corresponding to every category X, every data point X. In regression, you need to find a continuous value. There is not a classification task, it's a continuous value. So you must predict this continuous value there. So forecasting is one of the tasks. Say there are process optimization tasks. We will see multiple regression tasks. Classification, remember the classification you need, there will be a corresponding label, and these labels will be a discrete set. There will be a few number of sets. Say for example, 10 classes will be there, 20 classes will be there. So in animals, say there are how many? There are only countable number of animals that you can find in the images. But a number between, if you ask you to predict the value between 0 and 1, there are infinite number of uh, number of numbers that are between 0 and 1. So regression is a prediction in the continuous space where they are just you need to predict the continuous values there. In classification, you need to predict a label corresponding to the set. The set is very small, not very small. It can be a large, but it's a manageable set. You need to just predict a label in that set. So this is what the supervised learning is. In reinforcement learning, it's entirely different than these two form of learning. In reinforcement learning, you have a reward signal that recall how did you first learn cycling. In cycling, you just had cycle and you started paddling in it, and by falling from the cycle, eventually you started learning that okay, maybe if I do this way I will fall on the ground, but if I cycle or paddle or handle balance my handle in a different way, I'm actually able to move forward. So it was a trial and error way of learning, right? This is how you learned how to bicycle. Even better, how children learns to walk. They start by they start standing, they try different form of movement, they fall, they receive feedback that once they fall, they are not able to move forward, they may have hurt themselves. And these feedback, they take these feedback and try different way of moving, and eventually they start walking. So reinforcement learning can be thought of as a trial and error way of learning, where the environment only gives you a feedback saying that this is in some form of feedback that this is a correct way of learning or this is not a correct way of learning. In cycling, the reward is that when you fall, you get pain. So pain is the signal that tells you that you should not do these behavior, you should do something else. What you should do, we don't know. But do something else because doing this thing is causing you pain because you are falling on the ground. So is the difference between all these three categories clear? If someone can say something, I need to check message ka. Okay, I will check messages then. Okay, no questions. Okay. Okay, so this is the main difference between all the three categories. So we have unsupervised learning, we have supervised learning, and then the other category is reinforcement learning. So supervised learning, you have a data and the corresponding label. Unsupervised learning, you do not have the label, you have only the data, and you need to find some insight from this data. Now, reinforcement learning is entirely different paradigm. Here, you don't even have any data. You just have the environment where you need to learn certain tasks in that environment, and the environment gives you some form of feedback, like whether it is good or bad, some signal it will give you, and you need to acquire different skills. You need to complete certain tasks. You need to learn some different behaviors. So, but reinforcement learning, I don't think we are covering reinforcement learning in this. Um, uh, Workshop or lecture. So we will be mostly focusing on unsupervised learning and supervised learning. And today we will be looking at the supervised learning, one form of supervised learning called linear regression. So let's look into the other form. Okay, so we already covered this part, the distinction between supervised and unsupervised. Supervised learning, you have a continuous data or a categorical data. If you have a continuous data, then you do regression. If you have a categorical data, you do classification. In unsupervised learning, if you have a continuous data, you can do dimensionality reduction. Even clustering is also possible, but it's mostly when you have a categorical kind of data, people generally tend to do clustering problems becomes much more important there. So you have these two form of learning too. Now we will now look into a supervised learning method called linear regression. Now linear regression is a very simple method where you have the goal of a linear regression is to find the best line that predicts your data. So don't worry about all these points. I think we are sharing the slides after the lecture, so you can go through the points one at a time. But I will see. Okay, I see the images are not very clear. But what it means is that, let's say, for example, linear regression. is, say, given these all these green dots that you see here, these are the data points. What it means is that for a corresponding value of x, you have a corresponding value of y. So each point is a x comma y point, and these data points are generated. Now, given a new data point x, your goal is to predict what will be the value y. So in such cases, what the goal is that can you predict the value of y, and how are these data generated? The best explanation for all these data points is to fit a line on this data set, and this line is able to best predict these points. So if you have another point, say a point corresponding to 6, what would be the value? The best guess that you can make is that the point value would be something around 7,000 or something, not 7,000, 7,500 or 7,800 approximately, or 70,800, 70,000, 78,000 or something, right? Because all these data points are somehow, this line best explains all these data points. Why are all these data points away from the line? Because it may have some noise in it which you are not able to measure. So in real world, you can think of that all these data points that you see here comes from some real world data, and all these, where does this noise come from? Maybe when you measure, the measuring instrument that you are using, they also have some noise in it. So all these noise are some noise which you are not able to measure, and those noise reflects in these data points. So what is the best that you can do is that you can fit a line in it. Not the, this is not the best, this is the very basic model, linear regression, but one of the most powerful model. You fit a line on this data set, and if the line explains this data set properly, you say this is my model. Now, if you give me any point, I will be able to tell you what would be the corresponding best guess corresponding value of y. So if you have an experience of 6 years, you get around a salary of 78,000 or something. Now, so based on this, you can tell what is the approximate salary that you will get based on your experience. Okay, so these are the data points, and this line explains these points really well. That's what linear regression does. Like, it fits a line to this data point. It's not correct to say line, because okay, we will see all these things, that whether it is always a line, can we make it a curve? Say, what about if you have the data points were generated from a quadratic equation or some non-linear function? Will the linear regression still works? Actually, you can not just fit line, you can fit any form of curve though. You just need to make the degree of the very independent variables high. But all these things, I think we will see all these things tomorrow when we do the tutorial notebook, the hands-on notebook though. Today, for the time being, just assume that it fits a linear line on the data points. And learning the linear regression is actually very fast though. Like, you can learn in a closed form in some cases. Okay. So another form of doing class, so this is linear regression, where you try to predict a continuous value. Given x, you predict a continuous value. You can see the salary can be a continuous value. Okay, so that's why linear regression. Now the other part in supervised learning was classification task. Even though the name says logistic regression, but this is actually a classification method though. So logistic regression is used for classification tasks, and it is one of the most powerful algorithm to do classification. And how do you do? I think we'll see this thing in slightly in more detail. So what it does is that here you take a data x, and it tries to predict the probability between the two classes. So in the logistic regression is generally used for two class problem, where you have only two classes, and you want to predict whether this data point x belongs to class 1 or class 2. So a gender, whether a given image, whether it is a cat or a dog, that's what it is trying to predict. So it's generally a two-class problem, and there are so many two-class problems. Consider, for example, a spam detection. Like your Gmail has a spam detection uh, algorithm that is running in the backend, which actually is a classification problem, which says whether it is a spam or a not. If it is a spam, then predict one. If it is not, predict zero. Now, diagnosis, like whether you have any person has a certain disease or not. I mean, the disease can be any disease. Whether this person has this disease, cancer or not, zero or one. There are many other examples. For example, you need to predict uh, whether it is going to rain today or not, zero or one. So binary problems, the binary classification problem, even though you feel like oh it is very weak, but there are n number of problems or important problems where it fits into this binary classification problem. So what it does, how it solves this problem is that if you pass a data point, the logistic regression, if you pass a data point x into it, it will predict the probability whether this data point x belongs to class 1 or class 2. So it's a single probability. Say it predicts a probability of belonging to class 1 as 0.5, no, 0.3. What is the probability of belonging, would be the probability of this data point belongs to class 2? Say for a data point x, logistic regression predicts that the probability of this data point belonging to class 1 is 0.3. Then what is the probability that it will, what would be the probability of this data point belonging to class 2? Is someone answering? Amit? Mm. Uh,
Sir, can you repeat the question?
okay, let me write this. So say this predicts this is x. So x is some data point, and it predicts the probability is 0.3. It is very difficult to write, but somehow I'm trying. So the 0.3 is the probability that this data point x belongs to class 1. So what would be the probability that this data point belongs to class 2? What would be this number?
0.6.
Why 0.6? The person who answered, but why 0.6, if she can explain why 0.6?
I just added 3 number.
3 number. Why 3 number? Oh, you just added 0.3 plus 0.3?
Yes.
Ah, I, okay, okay. Achha, before okay, let me actually see. Mm, where everyone is able to follow linear regression first? I should have asked this before I moved to logistic regression. But was everyone able to follow linear regression? Now, I didn't do any math because it's a very first class, and I did not want to bring all math here. Uh, but was it the basic idea clear though, that we want to fit a line that best explains the data? For the time being, we will see that this is not just line, you can fit any form of curve, any complicated curve on this data point. But for today's class, let's assume that we fit a line on this data, best line that explains the data. Can someone please answer? Because I feel like otherwise it will become a very monotonous class that I will continue speaking and no one is able to follow. Then I feel like what is the point of even completing so many courses, so many topics, if we are not able to learn at least one topic properly? I'm happy to go to one of repeat some of the topics again. So is linear regression okay? Not okay.
Okay, sir.
Okay, thank you. Okay, so tomorrow we will see in more detail that how are these best how can we mathematically represent all these points. But for the time being, today just take this for a value. Uh, just assume that it just you try to find a best line that explains the data point. In logistic regression, since it's a classification problem and there are only two classes here, class 1 and class 2. So we say we denote class 1 with 0 and we give class 2 a label called 1. Okay, and I wrote somewhere, okay, it got deleted. So the data point, if you pass x, it actually predicts the probability that it belongs to class 1 with 0.3. This is class 1, and with what probability does it belongs to class 2? It's actually 0.7, not 0.6. Can anyone explain why it is 0.7?
Sir, the probability is 1.
Yes, this is why it is. Because I told you, right, that it is a two-class problem, that it has to predict either it belongs to class 1 or class 2. If it belongs with probability 0.3, it belongs to class 1, then it will definitely belong with probability 0.7, it will belong to class 2, because there is no other class, right? The data can either go to class 1 or class 2. And with class 1 it is 0.3, then definitely with class 2 it is 1 minus probability of belonging to class 1. Oh, I need to figure out how to write. Okay, so 1 minus p of probability of belonging to class 1, which is 0.7. Is this clear? Uh,
Yes, sir.
okay, so the thing is, notice this thing, that it just needs to predict a single probability value for C1. Can you tell me that if I give you this information, which class this point X you will assign to, class 1 or class 2? Like if I ask you that this data point X, what is the label of this data point X? Class 1 or class 2?
Class 2, sir.
Yeah, it is class 2, right? Because with a higher probability, it is 0.7 probability it belongs to class 2. And with 0.3 only it belongs to class 1. Now let's do another task. Now for class 1 you have zero point 0.1, and with 0.9 the data point belongs to class 1 with probability 0.9, and I will not tell you what is the probability for class 2. Now you tell me whether this X belongs to which class, class 1 or class 2?
Class 1, sir.
A class?
Class 1, sir.
Okay, class 1. Because with what is the probability of class 2 here?
0.1, sir.
0.1. Okay, now everyone is able to follow. Now I think someone else needs to answer. Now for class, let me delete everything. Okay, I didn't delete. How do I delete such thing? Eraser is there, I think. Eraser, okay. Let's write again. So again the same thing, X, you have C1, you have C2. Now I want someone else to answer. Now, now with probability point 2, this X probability is 0.2. Which class will you assign X to?
Class 2, sir.
Class 2,
Okay,
sir.
okay. Now with probability 0.5, which class will you belong? X belongs to?
Both have same probability, sir.
Yes. So in such cases, it becomes even more difficult. The point, okay. So this is like we can't say. We can't say, right? We can't say because our model is confused. It would ask that please someone help me. I can't say which class it belongs to. What about this number? What can you talk about this? 0.4. Which class this X belongs to?
Class 2, sir.
Class 2. Okay. Now, what about this? What about this? Which class this belongs to?
Two, sir.
Why someone said 2?
Because 1 minus 0.499.
1 is 0.4 is 0.501, sir.
Okay. The thing is that it has become so minimum gap that the model is now getting confused. Here also you can't say with very surety that whether it belongs to class 1 or class 2. Yeah, we can definitely do all these things, like let's say 0.5 is the cutoff, and what you are currently doing is that anything that is greater than 0.5 you assign it to class 1, anything less than 0.5 you assign it to class 2. This is what you are doing, right? Right?
Yes, sir.
Anything that is greater than 0.5 you assign it to class 1, anything greater than less than 0.5 you assign it to class 2. So this is less than 0.5 you assign it to class 2. But look at these numbers. These numbers are very close to 0.5, and we cannot really say whether the model these numbers are generated either by some error, some approximation, or is the model really not confident enough. So in these cases too, you cannot say that the predicted output is class 2. It's also same as 0.5, 0.5. 0.4, it has a very less confidence. So if I want to ask you, which among these will you trust your model the most? That okay, the output on this, the data point, this is x1, this is one data, this is x2 data, this is x3 data, this is some data point, and this is x4 data. So for x1 you said class 2, x2 you said you don't know, x3 you said it belongs to class 2, x4 you said it also belongs to class 2. Now tell me, what is the confidence, the classification confidence? So x1 data point, what is the how confident do you think you will say for sure that okay, this belongs to class 2? How confident you feel? You feel confident to say that it is class 2? Partially, yes, right? It's like with 80% probability, the model is saying that it belongs to class 2. So you feel like the model is confident with 80% though. But what about class 4? How confident do you think you will be when you say that, oh, it actually belongs to class 2? Like say, for example, if you have to put, say, 10,000 rupee, that will you put 10,000 rupee for class 4 or classification for class 4 or classification for class 1? I don't think you should put it anywhere though. But just let's say play a intuitive game. How confident do you think that you will put in class 4 though? The classification of class 4, data point 4. Do you think it is confident enough to say class 2? Which one has more confidence, data point 1 or data point 4?
Data point 1, sir.
Okay. And why were you able to say such thing?
It has the highest value, 0.8, sir.
Yes. So the point is that the lower it gets to the boundary line, the boundary line is 0.5. This is how you set the boundary line. The boundary line 0.5, you somehow chose this boundary point, and as the model starts predicting close to 0.5, your confidence also drops significantly, right? That's how you are able to say that, oh, this is for with 80% probability it belongs to class 2. Here it is like 0.5, 0.51, which is like, should I even trust this number? Because the model itself is not so confident. With 0.01 confidence, will I actually, not 0.01, it's a 0.00001, right? Will you trust such model that with 0.00001 a confidence I am saying that it is class 2? That's the only difference, right? So it is not very confident here in 0.4, but here the model is confident. So this confidence thing is very important when you actually use your prediction. Say now if you go for a loan application and your bank rejects your loan application, say if it rejects because you belong to this category 4, it's like you can go, you can see that this is a problem, right? If you belong to class 4, say some person went to a bank, C1 is a category whether you will get a loan, and C2 is a category which says you will not get a loan. If you see in class 1, if you belong to this data point 4, like some person 4 comes in and the logistic model predicts 0.49999 that this person should get a loan. And based on this classification, if you just directly blindly do 0.5, you will reject his loan application. Correct? Can someone say correct?
Sir, can you explain once again?
Okay. So consider that these x1, x2, x3, x4 are some real human being. Like x1 is one person 1, this is x2 is person 2, x3 is person 3, x4 is person 4. And you passed, this is your logistic regression model. You pass your, I have not explained what how this model is trained, but assume that it is trained and it predicts this number 0.49999 for person 4. C1 is a class where you will get a loan. Loan you will be approved, and C2 is your loan will be rejected. Okay. So with 0.49999, the model says that you should get loan. Right? But if you have been very strong, like, okay, if you say that strongly or confidently, you say that I will reject the loan, as you said, someone said that it belongs to class 2, that means that you will put person 4 in class 2 category and his loan will be rejected. Correct?
Yes, sir.
But is this enough? Is this enough confidence to reject his loan application? No, right? Or will you reject? Are you people? Are you guys so strong that no, we will reject? If the model says no, then we will reject everything. I'm sure that no one will you reject this application, or will you reject the application of this person?
No, sir, we don't reject.
Okay, so in this case too, you say that the model is not confident. The point is that every function that you train and the output has a real consequences, and not just this, you need to predict these values, you also need to predict the confidence score. So we call it confidence score, that how confident are you with your predictions? And based on this confidence score, we can let the human decide whether they want to take action based on this classification or not. Here the model is confident that with 80% probability you can reject his loan because he may have a very low credit score. That person may actually take the loan and run away, may never come back. But here the case is entirely different. The model is not confident at all. So here you want some human being to become part of this process and help make the decision. So we will see different ways of handling it. That how can we handle such very serious cases, that when we should ask help, should we even have the class called reject, or should we call this reject application as ask for help? Like ask human whether we should reject or not. take case like, oh, you will get a loan application, you don't have to ask, or the class 2 would be like ask. Class 1 is no need to ask, you can just approve. Class 2 is you ask because I am not sure whether you should get or not. That would be better, right? Like if it the number, but that also has a problem. What if I make it like 5000001? Here too, the model is that just 1 point confident whether you should accept or reject. So in all these cases, we will see these cases can be handled if you have a confidence score, that how confident is the model about its own prediction. And we will see in the coming lectures that it is not just okay just to give a prediction number, whether it belongs to class 1 or class 2, but it is also equally important to have a confidence on these numbers that you are predicting. If the model can confidently say that this number that it is predicting is with this confidence, that I am confident about 0.2, say with probability 1, then I will trust that it is, then I will reject this person's application. Here the prediction is so close that the model itself will feel like, okay, I don't know what class I should assign, so please a human come and do this thing. So confidence is also important. Okay, so this was all these things we did just to explain this point. But like, okay, hope I was able to explain this idea that we also need some confidence about this, and there are different ways to handle this. We will discuss each of these things later in this course. So is this point clear? Okay. Was I able to explain this point properly?
Yes, sir.
Yes, sir.
Okay.
Yes, sir, please.
Okay, so please do not hesitate to ask again. I'm okay to repeat, go back and repeat some of the topics that we have covered even later too. Say for example, if you want me to repeat linear regression, I can go back and repeat. The hope is that by the end of this lecture, the entire lecture, you will be able to get some concepts really well, like, and use those concepts wherever you go and apply. Okay, so let's move on. But what is this linear regression? How do we train these models then? So first, before we go and train, so we need to know what the sigmoid function is. It actually is a very nice looking function. So it maps any point. If you have any point x, x, it maps it to between 0 and 1. So 0 and 1 is the probability value that we actually want to predict, and it takes x, and if you pass it to a sigmoid value, it actually just scales it between 0 and 1. So you can see that if you have a value close to here, it will actually get value very close to 1. It does not always go to 1. It is like at infinity it goes to 1. Though the plot here looks like it just directly goes at this point. Only at infinity it becomes 1, like asymptotically, and only at infinity it actually becomes 0. Not like here itself it becomes 0. Okay, so this is how the sigmoid curve looks like, and we will see all these things when we do Python notebook. We will see all these functions more clearly, that what happens if we change these values, how does the sigmoid function help. All these things will come in the tutorial then. I don't think there is any math here today. We are almost just completing. So linear regression and logistic regression. Okay, linear regression is actually a regression problem. Logistic regression is a classification problem. Now, linear regression, you predict the continuous value because it's a regression problem, and logistic regression, you predict the categorical value. So you actually just predict the category, the binary category 0 and 1. In linear regression, you fit the line. What is the best line that describes the data points? And logistic regression, you fit this S curve. You try to fit this S curve on this data point. How do you do this thing? I have not yet discussed, but just take it for the time being that you try to fit. So all these green dots that you see is the data points, and you try to fit a best curve that explains these data points. How do you do this? We will learn this part later. And in linear regression, there are many different things like okay, so this I think we will come later too. Okay, so I think I will come, all these points are slightly advanced. We will see all these points. So you measure accuracy here and here. You also estimate accuracy here. Okay, the output of these values are continuous value. Here is a categorical value, yes, no, 0, 1. Linear regression is required that the relationship between the okay, this all these 2 points, this point, these 4 points, we will see it requires slightly more math, and tomorrow we will see math and the tutorial, a hands-on tutorial. Okay, so let's slightly look into the logistic regression. It is just, so this is the S curve that we were referring to. This is 1 by 1 plus e power minus x. So if you see at point 0, it is 0.5. Like if you put x equal to 0, e power 0 becomes 1, 1 by 2. So at x equal to 0, it is half. And only at infinity, if you put infinity here, e power minus infinity is 0. So it becomes 1. And only at minus infinity, it becomes 0. So if you put minus infinity here, so e power infinity becomes infinity. 1 by infinity is 0. So only at minus infinity, f of x becomes 0. And only at infinity, it becomes 1. Okay. So this is what the sigmoid function is, or the S curve function is. And logistic regression is trying to fit the data point that best explain that tries to fit in this S curve, and we will see how it fits the data point there. But this is what the S curve looks like. Okay, so let's just do this thing. So if you have some x1 to xn are the independent number of variables, and b0 is the intercept. Let me see if I have some more. Do I have one right? Okay, I think I don't have much. I see. Okay. How much time do we have now? So it is 1 hour or 1.5 hour lecture though. Okay, we have 1.5 hours. Okay. It is 1.5 hour, right? Till 7:30, right? Hello? Yes? No?
Yes, sir.
Okay, okay. Okay. Okay, then we have some time. Okay. So let me do this thing then. Okay. So what it does is that, so you have seen this 1 by 1 plus e power minus x. Say your data point, so this, say your data point is x, and it has, each of these data point has this value x1, x2. So remember I told you that each x, the data point that you see, say only 3, is actually a vector of some numbers, right? So consider example of human being. So x is some person, x1 can be his age, x2 can be his gender, x3 can be his or her how do I say, weight, age, gender, and weight. Okay. Now let's say we want to predict gender. So x1 is the weight, height, and age. Weight, height, and age. Say x is a person category, and y is that you want to predict whether it's a boy or a girl, the gender of this person, so male or female. And x is the person's information. So x is a person information. So let's write person here. It's so difficult. Okay, so x is a person's information, and y is your output that you want to predict whether it's a male or a female. And each of these data points, for a single person, you have x1 says age, x2 says weight, and x3 says height. Assuming this information is enough to categorize male and female, which I think it's not, but let's just do this brain map. Okay, let's just map this for some reason. Okay, let's just add some more thing. What else we can add? To identify male or female, maybe clothing style. What clothing style? So x4 is the clothing style. What else we can add that will help in identifying this person as male and female? Some other category, so which I am not sure what all I can add. So there are some other categories. So all these x points that you see are some numbers, some feature representation of this person x. So is everyone with me till this point? what these x1, x2, x3, x4 means for a single
Yes, sir.
person x? Okay. So, okay, everyone is with me for timing. Okay. So now you want to remember that the goal is still to learn try to map our data point on this S curve. Now we have this a learnable parameter. So we call this as, okay, here we are calling it B. So let's call it B. So B is some number that we currently don't know. We want to learn these B's, B1, B2. Say there are xn values. So we have Bn values here. Okay, these numbers we don't know what these numbers are, but what we want is, and then there is another point called b naught, which is a single number there, some number. What we want is that we want to linearly map these numbers, so it becomes x1 b1 plus x2 b2. We will see why we are doing all these things, plus dot 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 xn bn plus b naught. Okay, so it's a linear scale, right? B1 is something that we do not know. We want to learn these B1s such that this quantity, we call this quantity as Z of X. Okay, so let's call this as Z of X, and 1 by 1 plus e power minus Z of X is the probability that X belongs to class male. That this is the probability that it belongs to a class male. Okay, now can someone tell me? We still do not know B1, B2, B3, Bn, right? So this thing we cannot calculate because we don't know what is B1, B2, B3, Bn and B0, correct?
Yes, sir.
Ha. But we know all these data points. What we want is that we want to find B1 to B0 such that this class, say for this class, this we also have a label corresponding to this Y, right? Say the label is Y. We want to find B1, B2, Bn, B0 such that for this data point it should predict male class. For another data point x2, like some x, we have so many x's, I think we should call it something, x bar 1. So some data point x bar 2, it should predict it's a female. X bar 3, it should predict female. For x bar 4, it should predict male. So we want to find, this is x bar, we want to find B's, B1 to B and B0, B0 to Bn such that for x2 it should predict female, for x3 it should predict x3 bar it should predict female, for x4 bar it should predict male. When you put in this form, is this part clear? You see, what we did was that we are trying to fit all these data points x2 bar, x3 bar, x4 bar on this S curve by finding these different B1s. And why we do this thing? Say if there is a new data point, once if the model is trained, if we are able to find all these B1, say we are perfectly able to find these B1, say a new data point comes x5. What we have to do to predict the gender of this x bar 5? We just have to put in this model. We first estimate z x bar 5, and then put put this number in this sigmoid function. It will predict a probability that this belongs to a male with say 0.6, and we can say say it predicts with 0.7, and then we can say, oh, this guy most likely belongs to a male class. This is the prediction. Pred. Right? Hello.
Yes, sir.
Okay. So our goal is that if we have we want to find this B1 to B0 to Bn such that the data set that we have, the data set is like the set of all x bar comma y. This is the data set, right? We will take all these data set and we'll try to find all the B1s to B0 by training. We'll take all the data here and try to find all the B0 to Bn such that it best explains the label y, corresponding label y. And once we are able to find all these Bn's, now give me any new data like x bar 5, x 105, x bar 100, and I will be able to predict whether it belongs to which gender, male or a female. Okay. So it is slightly different. Here what we are trying to do is we are trying to fit our data point on this S curve. So how many of you were able to follow all these things? Was it clear?
I have one doubt.
Yes, please.
Sir, is 0.7 is assumption?
Oh yeah, this was just an assumption. This is definitely an assumption. So you do not know what this x bar 5 is. So for this x bar 5, we want to predict what is the value of this. So how do we do this? Once you have found out all these B0 to Bn number, how you will find by fitting it on the data. So once you have figured out what B0 to Bn numbers are, you if you want to predict for x bar 5, you just take x 5, first find z x bar 5 just by fit all these points here, estimate z x bar 5 and put in this S curve or the sigmoid curve. Sorry, sigmoid curve equation 1 by 1 plus e power minus z of x bar 5. And this value, say it gives a probability with 0.7. It means that with probability 0.7, it is of class male. And hence you ended up predicting it's a male class because it's predicted 0.7. If it would have predicted 0.2, you would have said, oh, it's a female then. Because male cannot, male with probability 0.2, female is 0.8. So most likely it's a female prediction. So x bar 5 is female. So this is what you are predicting. Was it clear? Was I able to answer you? The person who asked the question, was I able to answer you? Or did I answer something else altogether? What should I assume? Was I not able to answer your question? Did she leave the class?
Sir, now clear, sir.
Okay, I was able. Yeah, this is the problem. Now all my writings went. Okay, shit, I need to rewrite again. So, but I am assuming that people were able to follow. Even if you are not able to follow, we will do all these things, all the math details again tomorrow. Mostly in Python programming. So we will see all these things again. So this is the whole reason that we want to find all these B1 to Bn, all these B1 to B0 to Bn, such that it best explains the data point. And how do you best explain? We want to fit in this X curve, this nice S looking curve. We want to fit into this curve such that if it belongs to, it's a very high probability, we will say that it belongs to class 1. And if it has low probability, we say that it belongs to class 2. That's it. This was the whole idea there. And how do we find all B1 to Bn? It's like we will see how you will fit the data to predict all these values in the next class though. Now the examples can be, there are many examples. This is one, the example that we did was male female gender prediction example. Here is another example. Here you have to predict what is the probability that this card, the transaction that you are seeing current transaction that you are seeing is a fraudulent transaction, or it's a someone is doing a mischievous activity detection. So your card might have been stolen. If you suddenly see that, so how will you do is that given the previous transactions, like where you have used your card before, like place, how much amount you have used, what time you have used. Say suddenly most of you, I'm assuming majority of us, use our, say, not just credit card, any debit card or phone pay, mostly in the morning period, like maybe in the daytime or maybe at an evening, but not at 4 a.m. or 2 a.m. The likelihood of we using at 2 a.m., 3 a.m. in the morning is less, right? And at 3 a.m., you suddenly see a 50,000 rupee or 1 lakh rupee of purchase, then it's more or less likely it should be able to predict that it can be a fraudulent activity that you are detecting. For majority of the people, not for like specific case, but it also depends on at what place you are using. Say for example, if you are using at this regular place, that if you have used such amount regularly at the same time previously too, then it may not become a fraudulent activity. So all these data that you see, that each person, say for example, if you have one credit card, so how do you do this thing? Let's rewrite it again. So you have this credit card X bar again. Here the X bar data looks like how much was the amount. So you, one of your data point is amount. The other point is place. Where do you have you used this? The other is time. At what time was it used? Or even say date too. Say date. So generally, why date is because I feel like there are, like say, important dates like New Year, Christmas, or any festival date becomes a important time where suddenly the activity increases. Then, so date also sometimes becomes important. Time is important because you don't you suddenly, if you see activity, very large amount activity at late night, or say late night, then you also want to keep that into account too. Place is important, as you know that if you are residing in Chennai, so majority of your activity, financial activity and transaction will be around Chennai. Suddenly you will not be transported to say another part of your world in Arctic region. If such thing is happening, then most likely it's a fraudulent activity. You cannot directly reach Arctic circle. And amount is important, that if majority of your transactions are always within say 5,000 rupee, and suddenly you see a transaction of say 2 lakh or something any single on any single instant of time, then more or less likely you also want to know whether it is a fraud. To know it is a fraudulent, you add all these data points. Now X bar, what do you think could be another thing that you think of that we can add in this X bar, or what feature that do you think that we can add in X bar? Anything else that you can think that will help you detect credit card fraud or debit card or Paytm fraud? What extra information do you think we should know? Say something, anything.
Sir, some warning messages.
Okay, yeah. So these days, the bank have started sending you warning messages. But how will you add? But what is the purpose? So warning messages. What warning messages?
The pin is wrong.
The pin is wrong. Okay, someone is trying. Okay, this is interesting. Okay, so if you have warning messages, say if you received a warning message saying that the pin is wrong, even though you have not even tried one, then I think you can directly tell that it's a fraudulent activity. You don't need all these information, right?
Yes, sir.
But it's a nice one though. It's a nice one. Let's just add warning messages. Anything else that you think? Gender. Do you think gender is important for this to detect fraudulent activity?
No, sir.
Gender is useless. What is gender? Okay, anything else? Age. Do you think age matters? Do you think age matters? How do I delete this guy? Okay. Gender, people were able to reject it as soon as I said. Age, people are thinking. Maybe, right? Age, maybe, because
Sir, why the age to be added?
can someone repeat once again, because the voice was breaking.
Sir, why the age to be added?
You're asking why age? Can some, madam? I'm also thinking though. I'm also thinking with you. I'm just saying. Do you think age we can add?
Okay, sir.
No, no, I'm asking. I'm asking. I'm also asking that. Do you think age we can add or we should not add? Like gender, everyone agreed that gender is not an important feature to detect fraudulent activity, right? It doesn't
Yes.
matter whether you are a male or a female. What value will it have by adding gender there? But do you think age matters? Okay, let me say, I think age may give a good information. Think in this way. Say if you have, there are many schemes now that for younger children, like in government schools or so. So even when you are 12 or 30, the government asks you to create a bank account under your name, a minority account, and you have a bank account. The many young children today, like the teenagers, have bank account now. And suddenly in that bank account, you see a transactions happening of 1 lakh, 2 lakh rupee. Then you would actually want to alert that, oh, this can be a fraudulent activity. Right?
Yes, sir.
So age does become a factor. And if you see, majority of the fraudulent activity that happens in India are older people are generally the majority of their target. If people are following the scams that happens in India a lot, many of the time it's the older people. Our parents are at greater risk of these kinds of scam.
Yes, sir,
So
because they are unaware about that.
they are not familiar about say all these new apps like UPI, credit card, where these informations are getting leaked out, right?
Yes, sir.
So age do become an important. So if I'm the one who is trying to build a model, I must know what all features to add. Say amount. If you suddenly see 80-year old, say one of say our parents are currently around 60 or something. So suddenly, if say our parent age is say 65, and suddenly you see in her transaction amount of 10 lakh rupee, assume they have all retired, and if they have 10 lakh rupee, and if this is the amount that you suddenly see, you want your model to predict that, okay, please predict that it might be a fraudulent activity. It may not be. Like they say they are actually paying some loan that was pending loan was there and they want to repay that pending loan, then that's okay. But if it is not any random thing at time, say 3 p.m. in the morning, 3 a.m. in the morning, on the date, say any random date, some random ABC date. Place is not in Chennai. Say it is say some place in Kerala. So you will feel like, okay, this looks very odd, and it might be a fraudulent activity, right?
Yes, sir.
So age do becomes an important factor, given that how the current scamming is going on. So probably we can include age. I'm not saying that we even if we can build a better model without including age, but adding age is not an issue. So what we are doing currently is that not just building a model is important, but building your X data, the X bar is also important. What to include, what not to include. If you someone has given you gender, this gender information is useless. This is adding no value to it because men and women are equally targeted there. So you can simply drop this gender information. Make sense?
Yes,
Okay.
sir.
So yeah, so all these, so this is how you create your X bar and you have your corresponding Y. where whether this person X bar was whether this activity was detected as fraud or not, 0 or 1, and you trade your regression logistic regression model, and given a new data point, you can ask your logistic regression model predict whether it's a fraudulent activity or not. That's what we can do. Okay, so this is the example here. Now the other part, I think we are almost towards the end. I think how many we have a lot to cover. Okay, I think we don't have to cover everything today. Should we start this? Actually, let's stop here, because I think if I start this, if this is a new topic, this will become an important topic. I think we can start tomorrow fresh again. So tomorrow we will actually try to cover the remaining part, some more detail of how to do linear regression and logistic regression. Currently, we just saw what these models are capable of. We did not see the math in it, that how do we actually train all these things. These are nice, but how do we train those things? We will see tomorrow. How do we measure the performance? Like in the this got deleted though, but how do we measure that whether the 0.4999, whether you should whether you should say class 1 or class 2 or not? All those things, those confusing points. How do we actually tell whether we should assign a class 1 or class 2 or not? How confident do you think that this model is? How do you evaluate whether your model is doing okay or not? All these things we will complete tomorrow. We'll learn from this data point. We will evaluate all these matrices, and if time remains, we will also do hands-on session. If not, then we will do day after tomorrow. But depending upon, we'll see if we can finish it early. Then we will spend more time in doing a hands-on session. If not, we will just continue taking more doubts and questions. No, tomorrow. So let's stop here. I think today we will just stop at this point, 5 minutes early, because this is a new topic and this is important. Okay, okay. Any question till now? Let's take some questions though. If you have any questions, then we will take questions. If not, then we can close today's session. Any question, any doubt?
No, sir.
Okay. Okay. So if I will wait here till 7:30. If there is no, you all are free to leave though, and I will just wait if to see if someone has any doubt. I will just address them, and if not, then you are free to leave the class though. But I think I'm done. I will not be teaching anything new now anymore. So I will take all the other discussions tomorrow. Yeah. नहीं मतलब you all are free to leave though. You don't have to wait though. I'm just waiting if someone ends up asking. Someone is just trying to formulate questions or so. You guys can leave though.
Sir,
Yes. Yes.
I have a simple doubt.
Yes.
Can we use both the linear and logistic regression together?
Together to solve what problem? Okay. So I am assuming Monica asked this question, right? Am I correct?
Yes,
Somehow.
sir.
Okay. Okay. This time I was able to see where I had to look. Okay. So remember this thing. Logistic regression is a classification problem where you have a discrete set, like predict me in this set, cat, dog, a 0, 1 set. Linear regression is a continuous value prediction, a number between some range, right? Hello?
Yes, sir.
So in general, you cannot merge these two unless and until that problem setting is such that you want to predict both a classification task and a regression task. But in general, this note that I'm saying that it's in general you cannot. But it's not that linear regression cannot be converted into a classification problem too. Linear regression can also solve classification problem, but it is not generally chosen to do classification problem. Logistic regression, you cannot do a regression problem because it cannot predict intermediate values. It can only predict values between 0 and 1. You can definitely scale these values, but it doesn't work properly. Logistic regression, you cannot, it does not work well in regression task. Linear regression does not work well in classification task. But both of these methods can be used for interchangeably. Logistic regression works well only on classification, no, not only on, works well in classification task. Linear regression works well in regression task. And you can merge these two, but it is not generally recommended because they both are designed to solve different kind of problems though. Monica, was I able to answer?
Yes, okay, sir.
Okay. So, okay. Any more doubts? Anything else?
Sir, I have a doubt on sigmoid functions.
What is the doubt?
Sir, you say the infinity value is equal to 1 minus infinity equal to 0.
Yes.
Which is that doubt, sir.
Okay. Let me share my screen once again. Sorry. Okay. Is my screen visible?
Yes, sir.
Okay. So if you go towards infinity, if you put x equal to infinity, it becomes e power minus infinity.
Yes, sir.
So e power minus infinity is 0.
Yes, sir.
So it becomes 1. At x equal to infinity, it becomes 1. Right?
Yes, sir. Yes, sir.
At x equal to minus infinity, if you put minus infinity here, it becomes e power infinity.
Yes, sir.
E power infinity is infinity. 1 by
Okay, sir.
infinity becomes 0.
Yes, sir. Okay,
So
sir.
this function, this S curve function or sigmoid function is always between 0 and 1. Right?
Okay, sir.
That's what I was trying to say. That it can only predict values between 0 and 1. And that's what we
Okay,
need,
sir.
right? The probability is always between 0 and 1. And you need to fit all your data points such that it becomes nice, looking probability 0 and 1. Okay?
Okay, sir. Clear, sir.
Okay. So anything else? Okay, so we can close today's session. I was late for 10 minutes because of internet issues, and suddenly my Zoom was not working. Hopefully, I will
Okay,
be
sir.
able to come class tomorrow on time.
Okay,
Okay,
sir.
then. See you then. Bye.
Thank you, sir.
Then I will close this session today.